Hi! So you guys might remember my adventure into making a different style high voltage capacitor. Well, that thing failed. But I'm not satisfied with that failure. Today, we're going to try and get it right. I'm Alex, and welcome to the Renaissance Builder. Okay, so the general idea of this is pretty much the same. We're going to laminate aluminum foil on top of a plastic, and then we're going to wrap that plastic up and stick it in a jar. But the execution is different. This time I got a giant piece of plastic, and instead of gluing the aluminum to the plastic, I actually got this foil tape, which the foil is actually a bit thicker, so that might even help us out. And we're going to do, actually fill the jar, which is why I got the giant plastic. One thing I will say, this plastic came from Staples. Got the plastic from Staples. It's a little thicker than I wanted. I actually wanted a thinner plastic. This is a desk cover. But we'll find out. We shall find out if this works, because we're going to use it and try it out. Now the execution is pretty simple. I am going to measure the depth of our jar and then cut the plastic to fit this jar. Then I'm going to laminate the tape, the foil tape, stick it to that plastic. So we'll need 2 strips of plastic and 2 strips of foil. To keep it simple, I'm going to take 1 strip of plastic, put a foil on one side, foil on the other side, as identical as possible, leaving the margins wide. So where we failed in the last one is our margins were too small, so that the voltage was actually jumping right across our gap where the foil ended and the plastic ended. It was actually jumping right across that to the other lamination. So that was our problem with the last execution. So in this execution, we're going to keep our margins nice and wide, because I'd rather have a solid capacitor that's not going to blow up, that maybe is a little less microfarady. Whatever it comes out to, we can always refine it afterwards. So let's go ahead and get to working on this. We're going to do a little fast forward, measure this, cut this out, and get to working on it. All right, now we have our 2 laminations of plastic here, nice and long. And what I'm actually going to do is I'm going to go ahead and roll these laminations up. And just to see what, or, if it fits, how much it takes up in the jar. Of course, when you're dealing with something thicker like this, it tends to, well, it doesn't roll up very straight. It delaminates. It could be better. Like, it could actually be a bit longer. But given the situation with what we're dealing with here, if we make it, we really can't make it any longer. So let's flatten this back out, separate these 2 pieces. They're annoying me. Flatten this back out. So now we want to laminate the tape onto this. And here's the tricky part. So here's what I'm going to do. Let's measure this out. So I've got 4.5 inches of plastic, and I've got a bit over 2 3/4 inches. So that leaves a 1/2 inch, so a little over a 1/2 inch on each side. Now, here's the other thing I didn't tell you about. I'm actually going to fill the jar, when I'm done with this, I'm actually going to fill the jar with oil. The idea being oil is a much better insulator than air is. So even if our margins are just a tiny bit under, hopefully the oil will provide enough other insulation and cooling to keep everything in check. That's the idea we're going for here. All right, so let me just roll out the tape here. Since the tape has a paper backing, we can actually get this rolled out. Let me get to a shinier, little nicer side. There we go. Do away with that. And let's roll out the tape and get her stuck. All right. Didn't go as smoothly as I wanted to, but let's get her smoothed out over here. And we'll work out the kinks later. All right. Okay, now at this point I have my one piece that I have both layers of foil on. So at this point, assuming, and I have to assume, that the plastic is solid and there's no pinholes for the voltage to jump through, then this, in order for the voltage to jump at this point, it literally has to go around this entire border area. Oh, look at that, it's creasing already. All right, so here's the difficult part about that is keeping this thing from well, it's going to crease a little bit. So that's probably the advantage of having it on two different layers, but we're going to go with it. So what I'm going to do now is take this layer, stick it over top, and I can't stick it over top like 100% because one layer has to move. It's just, you know, when you roll it up, one has to take up more space than the other. So that's just the nature of the devil here. But in fact, what I can do is use a bit of duct tape on the end to hold it so that it doesn't crease on me on the end. So that's what I'm going to do. At the same time, I can't forget that I have to put my wires in place. So I'm just going to reuse the wires from the old ones because the wires are fine. I might have to shorten them up a little bit because our borders were actually a little bit larger on that one. All right.
Okay. So I need to at least make sure that the wire is attached to this side here. And again, make sure to flare it out just for maximum surface contact. Alright. Put some tape on there.
Okie dokie. Now this side should also, the pressure of this being rolled together should also help reinforce that contact area. So the biggest important thing here is to make sure these strips are lined up straight so that when you roll it up, they stay straight. And I might even reinforce it. No, I can't reinforce it along that perimeter, but I am going to tape it along this perimeter just to make sure that it actually stays there. Now, mind you, the tape in the oil is going to like dissolve, like the glues will dissolve, and it won't last that long. But for now, it should definitely do the job of reinforcing the plastic so that when we roll it up, we have a better chance of rolling it straight. And that's the difficult part, rolling this straight. Now you'll notice I only put one end over here because that's the important end that we have to work with. Okay, so I got this piece of hose. I was looking for a piece of copper, but you know, hey, you do what you got. So let's go ahead and start rolling this and try and get it as straight. See, once you start rolling, then the lamination, this other piece starts delaminating. And the key here is to keep it as straight as possible. So you just have to be careful while you're doing this, understanding that the thing is going to move and it's going to want to go other places. The tighter this wrap is, the better your, well, actually, since we did it all on one layer, it really shouldn't make that big of a difference. And there we go. Now I'm going to go ahead and trim some of this extra rubber All right. And then I'm going to put a piece of tape on here to hold it. And what I'm actually going to end up doing is putting zip ties around it to hold it for good. But this will at least keep our placeholder, because you don't want this to come unwound. That would be annoying, to say the least. All right. Pull the little centerpiece out. And there we go. Now you'll notice I only have one wire in here yet at this point. That's because the other terminal is right here on the outside, so I can go ahead and put that wire on now. So cut that to here. Do the same thing, make sure it lays out nice and flat. All right. And I'm going to take a piece of tape. To hold that on there. All right. Now, let me get a couple zip ties. That's one. That's two. Now at this point I'm going to take a couple zip ties just to fasten this sucker up, making sure that it should never come unwound. I want it nice and tight. Cool. I'm going to cut these zip ties. I'm going to trim them. Now let's make sure the whole thing actually fits in the jar. There it is. There it is, peoples. Now let's go ahead and see what kind of farads we're dealing with here. I mean, honestly, making capacitors, there's a few things that go into it. Like one style of capacitor that I've seen, which apparently isn't quite as popular anymore, is the glass stack capacitor, which means you take like your aluminum on a piece of glass and then let you literally layer it. So it's a whole bunch of parallel circuits. So apparently that isn't as popular anymore, but I've seen that. Maybe that would be an experiment worth having. All right, what are we dealing with? Oh, nice. 1920 is going up. Let me get the prongs on here real nice. So it's reading 7 nanofarads, which is still better than what we were dealing with, but it's still less than what I was hoping for. A lot of that a lot of that is probably due to the really thick nature of this plastic, but still 7 nanofarads is a lot better. And if I could, oh, I have clamps right here. It may be better if I get a good connection via clamps than just leaving it open like that. So let's get some clamps on here and see how that affects it. Yep, 8 nanofarads. All right, so that's what it is. Now, to top that off, I'm going to fill this up with oil, like I said, and here's the trick. I have, I don't want an oily mess going on over here, so I figured I'd put a lid on it. Now, I have this lid, but putting a metal lid on top of a high voltage capacitor just seems kind of not a good idea. So what I'm going to do is trace it out and cut it out of this here piece of acrylic. All right, so I put my 2 holes in here for the wires. Now that I have my lid made and our core is made, now we're going to add the oil. This is just standard mineral oil. It's the same stuff I have in the computer, which, by the way, the power supply sits in. So I know it's a good insulator. So we're just going to go ahead and fill this up. Oh, of course I make a mess. All right. Seems good enough to me. Let's go ahead and thread in our wires. Cool. There it is. Here is our capacitor. Now, it's insulated. The oil adds a bit of cooling in case it gets hot in there, which I don't know why it would, but it's there. And that should be very well insulated, so that should work. So let's go ahead and see if that made any kind of a difference to our values here as far as capacitance goes. Well, pretty much still just 8 or 7 nanofarads, but we should be able to handle a lot higher voltage at this point. So I'm going to go ahead and set up our Jacob's ladder again, wire this sucker in place of our wine bottle capacitors, and see how she does. All right, now I have this thing hooked up the same way that my famous capacitor discharge or capacitive discharge Jacob's ladder was hooked up with the wine bottles, only now instead of 2 giant wine bottles, we have this one smaller capacitor here. And it should do pretty much the same thing. More powerful capacitor. I don't know what it's going to lead to. We should be fine with everything going on in this here capacitor because like I said, the laminations are on one piece, so there's no way it can jump across that piece. And all the wiring is good. Well, that's different. Yeah. That's definitely different. So, let's see. Wow. The Jacob's ladder is performing significantly better. I think I can open that gap up actually quite a bit. The capacity, yeah, it's working better. So let's go ahead and open up the gap and see what happens. Trial number 2. So I'm getting the idea that maybe sparking, my spark gap being right there, like I guess maybe I have too much power. Like the transformers are doing too good of a job because it just straight up does that. Maybe I could try, let's try making this here piece wider. Yeah, let's see how that works. So the thing is, it's jumping from the, yep, okay, I see, path of least resistance, so it just jumps right across to there, all right. All right, so here's what I'm thinking at this point. What I need to do at this point is separate our ignition gap from our actual ladder gap. I think if I separate those two, like I could just straight up have the ignition like right here. I think maybe that would actually make a massive, well, if I separate the two, I think maybe we can, I mean, right now it's just jumping across wherever it can. Which is interesting, but that's not what I want. So in a controlled environment, I want it to spark in one place and then jump the gap in the other place. So let's see how I can figure that one out. By the way, this experiment is already a success in that our capacitor is doing just fine. I don't know if you guys noticed that, but this capacitor sitting over here just going, hey, how you doing? Oop. I need a bigger wire if I'm going to do it this way. Bigger wire. Where are you? Tighten this down. And what I'm going to do now is separate. This is going to be the dirty way. I'd have to make it pretty another way. But what I'm doing here is I'm separating the spark discharge. So this leg is now dead. And I'm using this just to this other line, and I'm just putting it up here so you can see it. But yeah, if I come over here, then I should be able to do the spark line just the same, just at a different spot. Alright, let's try her out. Nope, not close enough. I saw smoke. What was the smoke? Uh-oh. Did our capacitor short out inside? Yes, it did too. It did. It did. You bastard. Oh, man. Look at that. Alright, camera shake time. Alright, so check it out in there, guys. Yep. She's a smoked. Capacitor went and smoked inside there. Dang it. Alright, so that's very disappointing. It's very disappointing. Now I have to open this sucker up. I mean, the only way it could have jumped that is, well, quite frankly, the only way it could have jumped it is right through the plastic, so the plastic wasn't strong enough. Back to the drawing board again. I'm really tired of failing at this thing. I might just jump right to the glass. You know, everybody on YouTube makes these videos, and they're like, this is how you make a capacitor. But then they don't actually stress that capacitor out, and I mean stress it. And then their capacitors look great. Well, once you put these homemade capacitors to a stress test, they don't actually hold up. Like, this is a better built capacitor than I've seen a few times. So, whatever. We'll figure it out eventually. We will. Shoot, I might even just stick with the glass bottles because they work well. Anyhow, that was our experiment in trying to make this capacitor thing again. So, if you guys like this video, go ahead and hit that thumbs up. Make sure you're subscribed and that you hit that bell icon so you can see the videos when we do finally succeed in making a capacitor that, you know, holds up to our stress test. Which, by the way, this is a very, very hard stress test. We got 12,000 volts at 0.06 amps. So, I'm not putting I'm not easy on this thing. So that's why they're failing. But, anyhow, if you guys want to see when this thing is actually successful, make sure you're subscribed. Make sure you have that bell icon clicked. Hopefully you enjoyed this video, so you throw a thumbs up on this thing. Feel free to comment if you guys actually have an idea how to make these here capacitors so they do hold up. By all means, I would really appreciate your input. So leave a comment. I would really like that. Until next time, guys, you have a good day.
Bye-bye.